Refraction of light. When a light ray passing from one medium to another medium, it bends. This phenomenon is called as refraction. Why the light ray is bending? When a light ray travels from one medium to another medium, the speed of light changes. So, it bends. Let us take a few examples to understand this. Here, the pencil looks like bending because the speed of light is in air and water is different. That's why it bends. This phenomenon of bending of light at the interface of two media is commonly known as the refraction of light. The bending of light ray depends on the refractive index of two media. Let us take another example to understand the refraction. Here, in this glass, you can observe an arrow mark. Carefully observe the direction of arrow mark. See, the direction of arrow mark is reversing because of refraction of light. Behavior of light ray during refraction. When a light ray traveling from one medium to another, it doesn't travel in the same direction, it bends. This is called refraction, and the bent ray is called a refracted ray. And the perpendicular line striking on that point is called as normal. Light can bend towards or away from the normal line. Let us see examples. When light travels from rarer medium to denser, it bends towards the normal line. When it travels from denser medium to rarer, it bends away from the normal. Here, the light traveling from air to water, so it bends towards the normal. When a light ray travels from glass to water, that is, denser to rarer, it bends away from the normal line.
Hi everyone, this is Irfan. So now we are going to discuss about refraction of light. What is refraction? When we observe this phenomenon, so let us try to understand about this quality of light. See, the light travels from one medium to another medium. What is the speed of light in vacuum? So the speed of light in vacuum is 3 into 10 to the power of 8 meters per second. That means around 3 lakhs kilometers per second. With this much of speed, the light travels in vacuum. When it travels from one medium to another medium, what happens? When the medium changes, the speed of light changes. That's why the light bends. That means it changes its direction. This quality of light is called as refraction. Let us try to understand this quality with some examples. So here I have a pen. Now I am going to put this pen into this glass of water. What happens? Observe carefully. You can observe the difference in the pen which is inside the water and which is outside the water. See, the part of pen which is inside the water, it is looking bigger than its original size. And also at the interface, that means where water and air meets, at the interface the pen looks like it has bent. Is the pen originally bent? See, the pen is not bent, it is straight in direction. When I put this pen into the water, it looks like it has bent. This quality of light is called as refraction. Why this is happening? Because the speed of light is changing. Here we have air and here we have water. That means two different mediums. When the light is traveling from air to water, that means two different mediums. So it looks like the light ray bends. This quality is called as refraction. Let us take one more example. Here I have a lemon. Observe the size of the lemon now. What happens when this lemon is placed inside the water? So into this glass of water, now I am going to put this lemon. Observe the size of the lemon now. So it is looking bigger than its original size. Why this is happening? This is also because of refraction. Now in this class we are going to discuss why this is happening. Why some objects are looking bigger than their original size. Why the light ray bends. So these are the topics now we are going to discuss in this class. See, just before we have discussed that when light travels from one medium to another medium, it changes its direction. That means it bends because the speed of light changes. How the speed of light changes? How to find this quality? Now let us discuss. First of all, let us take this case. That means when light ray is traveling from air to glass. So two different mediums we have. So in this case, the light ray is traveling from air and it is entering into the glass. What happens? Before going to that, let us try to know few basic concepts of this topic. So this light ray which is traveling, this light ray is called as incident ray. So the light ray which is passing into the another medium is called as incident ray. And the light ray which is travel into the another medium, this light ray is called as refracted ray. Now, if we observe carefully, the angle between the incident ray and this line n dash, this line, this perpendicular line is called as normal line. So the angle between the incident ray and the normal line is called as angle of incidence. It is denoted by small I. And here the angle between refracted ray and the normal line is called as angle of refraction. It is denoted by small r. How these two values are, now we are going to discuss. Let us take the first case. That means when light ray is traveling from air to glass. So in this case, the light ray is traveling from air to glass. So this air is called as a rarer medium and this glass is called as a denser medium. That means when a light ray is traveling from rarer medium to denser medium, what happens? How the light ray bends. So if you observe this diagram carefully, when the light ray is traveling from rarer medium to denser medium, the angle of incidence is greater than angle of refraction. That means the refracted ray bends towards the normal line. When a light ray passing from rarer medium to denser medium, it bends towards the normal line. That's why the angle of refraction decreases than the angle of incidence. So in this case, the angle of incidence is always greater than angle of refraction. Let us take another case. That means when light ray traveling from denser medium to rarer medium. That means when a light ray is passing from glass to air. In this case, how it changes? Let us try to discuss. So this is the incident ray. This is the incident ray. That means the light ray is passing from glass to the air. That means from denser medium to the rarer medium. So this is angle of incidence and this is angle of refraction. The angle between normal line and incident ray is called as angle of incidence, and the angle between normal line and refracted ray is called as angle of refraction. So here in this case, how these two are, if you observe this diagram carefully, you can easily find out that the angle of incidence is less than angle of refraction. That means when a light ray passing from denser medium to the rarer medium, it bends away from the normal line. It bends away from the normal line. That's why the angle of refraction is always greater than the angle of incidence in this case. So angle I is less than angle R. So this is the relation between angle of incidence and angle of refraction in this case. And now, how to find the speed of light and how to compare the speeds of light, how to compare the materials. To understand this, we need to understand another concept, that is refractive index. So what is refractive index and how it is useful for us? So the refractive index, it is denoted by small n. What is refractive index? So the refractive index is this is also called as absolute refractive index. The absolute refractive index is defined as the ratio between the speed of light in vacuum to the speed of light in a medium. So speed of light in vacuum is denoted by C, speed of light in a medium is denoted by V. Then we can write the formula for the refractive index, that is absolute refractive index, N is equals to C by V. So this is the formula to find the refractive index of a medium. So speed of light in vacuum, its units are meters per second. Speed of light in a medium, its units also meters per second. So these two will get cancelled. So that's why we can get 1. That means the refractive index has no units. There are no units for refractive index. It is a constant value. Now, how this refractive index helps us to understand the nature of a material. So, as the refractive index of a material increases, the speed of light decreases. That means the material which has very less refractive index, the speed of light is very high in that material. If the material has very high refractive index, the speed of light is very less in it. For example, if you take air, the refractive index of air is 1.0003. That means almost equal to 1. That's why the speed of light in air is almost equal to the speed of light in vacuum, approximately equals to 3 to 10 to the power of 8. If you want to say exactly, the speed of light in air is 2.97 into 10 to the power of 8. That means almost equals to 3 to 10 to the power of 8. If you take diamond, the refractive index of a diamond is 2.42. So the refractive index of a diamond is 2.42. That means it is 2.42 times to the refractive index of air. That's why the speed of light in diamond is very less. The light travels very slowly in a diamond. That means the speed of light depends on the value of refractive index. So by knowing the refractive index value, we can easily find out the speed of light. That means how it travels in that medium. So these are the concepts basically we need to understand in the case of refraction.
Absolute refractive index. When a light ray travels from vacuum to any other medium, the refractive index of a medium with respect to vacuum is equals to the absolute refractive index of the medium. Refractive index is denoted by small n. So, n is equals to speed of light in vacuum divided by speed of light in medium. This can be formulated as c by v. We know that the speed of light in vacuum, c, that is 3 into 10 to the power of 8, is always greater than the speed of light in any medium. So, the ratio of c by v is always greater than 1. So, the refractive index n is always greater than 1 for every material. Let us know the values of refractive index of few materials. Air 1.0003, water 1.33, glass 1.50, ruby 1.71 and diamond 2.42. As the value of refractive index increases, the speed of light decreases. We know that the value of refractive index is a constant, so it has no units. Let us take one example problem. Find the speed of light in glass if the refractive index is 3 by 2. In the problem, refractive index is given, that is 3 by 2, and speed of light in vacuum, we know that 3 into 10 to the power of 8 meters per second. N is equals to c by v is the formula we used here, and by substituting the values we get 3 by 2 is equals to 3 into 10 to the power of 8 by v. After solving, we get v is equals to 2 into 10 to the power of 8 meters per second. Relative refractive index. When light travels from one medium to another medium, the speed of light changes. So, it changes its direction. That means it bends. Let speed of light in medium 1 is v1, speed of light in medium 2 is v2. The ratio of speed of light in medium 1 and speed of light in medium 2, that is v1 by v2, is a constant. So, the refractive index of medium 2 with respect to medium 1, that is n21, is equals to v1 by v2. Same like that, refractive index of medium 1 with respect to medium 2, that is n12, is equals to v2 by v1. If we take the product of n12 and n21, that is v2 by v1 into v1 by v2, it is equals to 1. By this, we can conclude that n12 is equals to 1 by n21. Snell's law. The angle of incidence and the angle of refraction satisfy the equation sin I by sin r is equals to n. Place a semicircular glass disc as its diameter coincides with interface. Point a laser light as the light propagates from air to glass through the interface at point O. Let the angle of incidence is 5 degrees. We got angle of refraction as 3 degrees. If angle I is equals to 10 degrees, we got angle R as 7 degrees. If angle I is equals to 15 degrees, we got angle R is equals to 10 degrees. If it is increased to 20 degrees, we get angle R as 14 degrees. If the angle of incidence is 25 degrees, we will get the angle of refraction as 17 degrees. We can continue the experiment like this with different angles of incidence values. Let us tabulate the angle I and angle R values and try to find out the ratio between sin I and sin R. In this table, we have tabulated the different angle of incidence values and the correspondence angle of refraction values. So here we also calculated the sine values of all angle of incidence values and also the sine values of all angle of refraction values. In the last column, we have calculated the ratio between sin I and sin R. If you observe all these all values are almost equals to 1.4. This constant value denotes the refractive index of the material of glass disc. So if we get the average of all these values, that means the average of all sin I by sin R values, we get 1.45. So this value denotes the refractive index. Hi friends, in this class we are going to discuss about total internal reflection. We know that when a light ray is passing from denser medium to the rarer medium, it bends away from the normal line. Hence, the angle of refraction is greater than angle of incidence. Gradually, if the angle of incidence increases, the angle of refraction also increases. At a particular angle of incidence, the refracted ray just grazes. If we observe the third diagram, as the angle of incidence increases, the angle of refraction grazes with the interface. That means for some angle of incidence, the angle of refraction has become 90 degrees. This angle of incidence is called as critical angle. That means at critical angle, the angle of refraction is 90 degrees. If the angle of incidence is further increased, observe the green colored line here. Here, the angle of incidence is greater than the critical angle. For this angle of incidence, the light ray doesn't undergo refraction. Here we observe reflection. That means if the angle of incidence is greater than critical angle, the light ray undergoes reflection rather than refraction. This is known as total internal reflection. There are some conditions for the total internal reflection. The first one, the light ray should travel from the denser medium to the rarer medium. The second one, the angle of incidence in denser medium should be greater than the critical angle. Let us try to understand this with an example. To observe total internal reflection clearly, we need a laser light and an aquarium. Here, if we want to observe this phenomenon clearly, better to add few drops of Dettol into the water. So observe here carefully. Here we are sending a light ray from one side of the aquarium. Here we can observe clearly that the light ray is reflecting into water itself, but it is not refracting into the air. Observe carefully. Here the water is reflecting into the same medium, that is denser medium. This is an example for total internal reflection.